Hello everyone. Let us now discuss how can we solve this question. Minimum operations to make binary array elements equal to 1. First part. Now, we are given with this nums array and we need to make all the elements equal to 1. So this is our question. But there is a constraint that we need to flip only 3 consecutive elements. What does this flipping mean? 0 will be converted to 1 and 1 will be converted to 0. That means XOR operation or a NOT operation. Now let us see how can we solve this question. First thing, I don't need any zeros. This will be my first observation. I wait a second. I I don't need any zeros. I have to eliminate zeros. So this is my ultimate goal, and when we are flipping 3 consecutive elements, this will be considered as one operation. Now this will be considered as one operation. So we need to return minimum number of operations. This is the question which is given in the description. Now let us see how can we solve this question. Now I got a 0. Let me say that here first thing I got a 0. So what I need to do? The thing is I need to change it to 1. So I need to flip it to 1. But as they asked in question, we need to flip 3 consecutive elements. So whenever I am getting this 0, so instead of only changing it, I cannot change only one element. I need to change 3 consecutive elements. So I am changing that to 1 and also this 1 to 0. That means flipping 3 consecutive elements. This 1 to 0. So these are the 3 elements that I have flipped when I got 0. So I'll stop there itself. Now I have 1 and I have 0 and also I have 0. Now I have again 0. So here I have to flip that 0 to 1. So let me first write this one here itself and I have to flip this 0 to 1. Can I flip only that element? No, right? So I will flip these 3 elements. So 0 is changed to 1 and another 0 is changed to 1 and 1 is changed to 0 and then 0 and then zeros as it is. Now when I iterate through this, I get a 0 again. Can I flip only that element? No. I should flip all the 3 consecutive elements from that index. So I'll write these 3 times 1 as it is. Now I am flipping these bits 1, 1, 1. That's it. So this is how you solve this problem. Like, now let us look at this example why this doesn't work and why we need to return -1. That means we cannot change or we cannot make any number of operations to get a one array. Now I have a 0 here. As I said, I need to flip these elements, 3 elements, so that I will make this 0 to 1. Now 1 is changed to 0, 1 is changed to 0 and 1 is as it is. Now I have this 0. So these 3 consecutive elements need to be changed. 0 is changed to 1 again, 0 is changed to 1 again and 1 is changed to 0 again. Now if you see, there is a 0 at index n minus 1. So at this point of time, I cannot change this. I doesn't have any 3 elements after this. So I cannot change at this time. I cannot change at this time. Do I have any other constraint that I cannot change? Yes, it is when I have a 0 here. When I have a 0 here, then as the operation say, we need to flip three consecutive elements. There are only two, so these two cannot be changed, and this last bit cannot also be changed. This last element can't be changed. So at this point, when my 0 is at the position of n minus 1 and n minus 2, then I cannot change the nums array to array which contains only ones. Now, imagine I am having something like 0, 0, and 0. Now, I have this 0 at nums or n minus 3 index, so I can simply change it to double one, double one, and I can make it a ones array. Now, you might ask, like 1, 0, 1, 0, what would be the answer at this point of time? As I said, this is the first 0 and I need to change three consecutive elements. So 1, 0 is changed to 1, 1 is changed to 0, and 0 is changed to 1. So here these three are changed, but this 0 is again at the position of n minus 2. So what I am doing every time? The firstly, let my operations are initialized to 0 and my index is also 0. Now, what I am checking always. So here, wait a second. Here I was at this index. Now, the next index which I checked is right after this, whether it is 0 or not, right after this. So, here my index will be I will be less than n. Now, I'll write this algorithm. So, if nums of I is 0, change the current plus 1, or let me write it as I and I plus 1 and also I plus 2 elements, or flip the I plus 1 and I plus 2 elements, right? Flip the I plus 1, I plus 2 and I plus 1, I plus 2 elements. Now, after that, imagine if I got nums of I at index. If I is at n minus 1 or n minus 2, then I should return at there itself minus 1. So this is how you solve this problem, right? Here, after that, this is another example. I will show you how this works after writing this algorithm. Now, after that, we will be returning operations. But don't forget to increment our operations every time, only when this nums of I is equal to 0. So this is the whole algorithm, but let us look at this example. Now I have this 0, right? When, as I said, here is my I and my operations is initialized to 0. Here is my I and it is 0. So I will change three consecutive elements, or flip three consecutive elements, as I said I plus 1 and I plus 2. 0 is changed to 1, 1 is changed to 0, and 1 is changed to 0, and next as it is. So I have changed or flipped. So my operations will be incremented to 1. Now, after that, my I will be here. So let us move this here. So my I will be here at 1. So at this index, I got 0. So the next, or the three consecutive elements are flipped. So 0 is changed to 1, 0 is changed to 1, 0 is changed to 1, and 1, 1. Now, my operations are increased to 2. So this is my next array which is having ones everywhere. my I value is 2. Does I got any 0 here? No. Now let me increment my I value here and then here and then here, and it will go out of range. So at this point, as I said, I plus plus I will be incremented every time. So this is how you solve this problem, and this is our algorithm at the end. And if you want the code, it is in the description. And if you look at the code, here it is. Operations are initialized to 0. N is num size. I is initialized to 0. It is the index. While I is less than n. If nums of I is equal to 0, then we need to do some operations. So these are the operations that I am flipping here. So if I is greater than n minus 3, that means if it is I is n minus 1 or n minus 2, then we will return minus 1. So I am incrementing I every time, return operations. This is how you solve this problem. If you like this video, do share it to your friends and do subscribe to my channel. Thank you.